Hi. Hi. Great. Looks like everything's working fine. This is a new stream, and I guess I expected to have no one on a brand new channel, brand new stream. Here on this stream, we will learn Linux from scratch. What is it? What is it about? And we'll do it all live with people that are interested. We will discover the world of Linux by taking a look at how it is built, and we'll build our own from the bottom up. Looks like Linux from scratch has already reached version 8.2. I guess it's expected. Almost 20 years of work has been put into Linux from scratch. I'd go into more details as to what this project is, what Linux from scratch is, but I guess the preface, the foreword, will tell us all we need to know. 1. Foreword. My journey to learn and better understand Linux began over a decade ago, back in 1998. That's 20 years ago from now. I had just installed my first Linux distribution and had quickly become intrigued with the whole concept and philosophy behind Linux. There are always many ways to accomplish a single task. The same can be said about Linux distributions. A great many have existed over the years. Some still exist, some have morphed into something else, yet others have been relegated to our memories. They all do things differently to suit the needs of their target audience. Because so many different ways to accomplish the same end goal exist, I began to realize I no longer had to be limited to any one implementation. Prior to discovering Linux, we simply put up with issues in other operating systems, as you had no choice. It was what it was, whether you liked it or not. With Linux, the concept of choice began to emerge. If you don't like something, you are more free. If you don't like something, you are free, even encouraged, to change it. I tried a number of distributions and couldn't decide on any one. They were great systems in their own right. It wasn't a matter of right or wrong anymore. It had become a matter of personal taste. With all that choice available, it became apparent that there would not be a single system that would be perfect for me. So I set out to create my own Linux system that would fully conform to my personal preferences. Now, who is saying all this? I guess it's the author. But at this point, we do not know who the author was of this handbook. Oh, I guess we know who the author is. Gerard Bigmans. So I assume he's talking. Maybe we'll find out. To truly make it my own system, I resolved to compile everything from source code instead of using pre-compiled binary packages. This perfect Linux system would have the strengths of various systems without their perceived weaknesses. At first, the idea was rather daunting. I remained committed to the idea that such a system could be built. After sorting through issues such as circular dependencies and compile time errors, I finally built a custom-built Linux system. It was fully operational and perfectly usable, like any of the other Linux systems out there at the time, but it was my own creation. It was very satisfying to have put together such a system myself. The only thing better would have been to create each piece of software myself. This was the next best thing. As I searched my goals and experiences with other members of the Linux community, it became apparent that there was a sustained interest in these ideas. It quickly became plain that such custom-built Linux systems serve not only to meet user-specific requirements, but also serve as an ideal learning opportunity for programmers and system administrators to enhance their existing Linux skills. Out of this broadened interest, the Linux from Scratch project was born. This Linux from Scratch handbook is the central core around the project. It provides the background and instructions necessary for you to design and build your own system, while this book provides a template that will result in a correctly working system. You are free to alter the instructions to suit yourself, which is, in part, an important part of this project. You remain in control. We just lend a helping hand, and you get started on your own journey. I sincerely hope you will have a great time working on your own Linux from Scratch system and enjoy the numerous benefits of having a system that is truly your own. Gerard Bickmans, gerard@linuxfromscratch.org. As we can see, this handbook gives us a lot of freedom. It has everything set up for us. We can build things exactly as they do. But we can derail from that, and I hope to do so during these live streams. We can derail from that and build our own thing, our own personal Linux. And I want to encourage you to do the same, because it's empowering to have your system. Whenever you show it to someone, it is your system. Whenever people meet your system, they realize that it's personalized for you, that you did it. It's very empowering to have your system to do whatever you want it to do. Up home next. There are many reasons why you would want to read this book. One of the questions many people raise is, why go through all the hassle of manual building Linux system from scratch when you can just download and install an existing one? And this is a good question. One important reason for this project's existence is to help you learn how a Linux system works from the inside out. Building a Linux from scratch system helps demonstrate what makes Linux tick, how things work together and depend on each other. One of the best things that this learning experience can provide is the ability to customize a Linux system to suit your own unique needs. Another key benefit of LFS is that it allows you to have more control over the system without relying on someone else's Linux implementation. With LFS, you are in the driver's seat and dictate every aspect of the system. LFS allows you to create very compact Linux systems. When installing regular distributions, you are often forced to install a great many programs which are probably never used or understood. These programs waste resources. You may argue that with today's hard drives and CPUs, such resources are no longer a consideration sometimes. However, you are still constrained by size considerations, if nothing else. Think about bootable CDs, USB sticks, and embedded systems. Those are areas where LFS can be beneficial. Another advantage of custom-built Linux systems is security. By compiling the entire system from source code, you are empowering to audit everything and apply all the security patches desired. It is no longer necessary to wait for somebody else to compile binary packages that fix the security hole. Unless you examine the patch and implement it yourself, you have no guarantee that the new binary package was built correctly and adequately fixes the problem. Is that really true? I guess it is. Though people that release security patches usually release them to fix problems. The goal of Linux from scratch is to build a complete and usable foundation level system. If you do not wish to build your own Linux system from scratch, you may nevertheless benefit from the information in this book. There are too many other good resources to build your own LFS system to list them all here. In the end, education is by far the most powerful of reasons. As you continue in your LFS experience, you will discover the powerful information and knowledge. You will discover the power that information and knowledge truly bring. For a second there, I got distracted, thinking as to how much is visible on the stream, because I'm streaming on a 16:10. Sorry. Da, tată. Nu dorm, da, lucrez. N-ai văzut? Ai acolo. Rog să nu deranjezi. Nu. That was a small distraction there. I was wondering if I'd get the silence to be able to stream properly. And I know I will. It just, when you're not alone in the house, there is work that you need to do in order to change how things are. Target architectures. The primary target architectures of LFS are the AMD Intel x86 32-bit and 64-bit CPUs. On the other hand, the instructions in this book are also known to work with some modifications with the PowerPC and ARM CPUs. To build a system that utilizes one of these CPUs, the main prerequisite, in addition to those on the next few pages, is an existing Linux system, such as an earlier LFS installation, Ubuntu, Red Hat, Fedora, SUSE, or other distribution that targets the architecture that you have. So one of these CPUs to build a system that uses one of these CPUs, the main prerequisite, in addition to those of the next few pages, is an existing Linux system, such as Ubuntu, Red Hat, Fedora, SUSE, or any Linux system. Also note that a 32-bit distribution can be installed and used as a host system on a 64-bit AMD Intel computer. Some other facts about 64-bit systems need to be added here. When compared to a 32-bit system, the sizes of executable programs are slightly larger, and the execution speeds of arbitrary programs are only slightly faster. For example, in a test build of LFS 6.5 on a Core 2 Duo CPU-based system, the following statistics were measured. 32-bit build time a little bit longer, build size a little bit smaller compared to the 64-bit. As you can see, the 64-bit build is only 4% faster and is 9% larger than the 32-bit build. The gain from going to a 64-bit system is relatively minimal, of course. If you have more than 4 gigs of RAM or want to manipulate data that exceeds 4 gigabytes, the advantages of a 64-bit system are substantial. I want to check this one more time. The preliminary target architectures of LFS are AMD and Intel 32-bit and 64-bit CPUs. The instructions work with other architectures. To build a system that uses one of these, so I need to get a Linux installed. I will. I'm currently running on Windows 7. We'll get a Linux. I do have another computer with Linux, but I think I'll use virtual machines as I'm streaming off of this one. As you can see, we've read that. Note, the above discussion is only appropriate when comparing builds on the same hardware. Modern 64-bit systems are considerably faster than older 64-bit systems, and the LFS authors recommend building on a 64-bit system when given a choice. The default 64-bit build that results from LFS is considered a pure 64-bit system. That is, it supports 64-bit executables only. Building a multi-lib system requires compiling many applications twice, once for a 32-bit system and once for a 64-bit system. This is not directly supported in LFS because it would interfere with the educational objective of providing the instructions needed for a straightforward base Linux system. You can refer to the Cross Linux from Scratch project for this advanced topic. Okay, this is like another handbook of theirs. They have more different books. They have Linux LFS, they have Beyond LFS or BLFS. This one's enough for now. We'll just go on exploring those another time. 4. LFS and standards. The structure of LFS follows Linux standards as closely as possible. The primary standards are POSIX. How do I spell that? POSIX.
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 POSIX. POSIX 1, 2008. File System Hierarchy Standard FSH version 3.0. I do not know what this is. FHS 3 specification brings the first update in years. Specification. File System Hierarchy Standard. So this is like the way directories are structured. It's not that much different from Linux. From Windows, we can relate to that. POSIX is a terminal standard, and it's a really standard. Issue 7 defines a standard operating system interface and environment, including a command interpreter or shell, and common utility programs to support applications portability at the source code level. So it's a standard for the way Linux systems work. All of Linux is POSIX, as far as I know, and Mac is POSIX as well. They all have that terminal in common. Linux Standard Base, LSB, version 5. I can find out about LSB here. The LSB has 4 separate standards: core, desktop, runtime languages, and imaging. In addition to generic requirements, there are also architecture-specific requirements. There are also 2 areas for trial use: GTK3 and graphics. LFS attempts to conform to the architectures discussed in the previous section. there are two areas for trial use, GTK3 and graphics. In addition to generic requirements, these are also architecture-specific requirements. Well, so which one are we using? Because there are 4 different standards. I don't know if this does matter, but if there are 4 different standards, then they are different to each other. So does not specify which of them it's used. There are generic requirements and architecture-specific requirements. 2 areas for trial use, GTK3 and graphics. GTK3 is like a window environment, as far as I know. This may be what? Or the GIMP toolkit is a multi-platform toolkit for creating graphical user interfaces, offering a complete set of widgets, GTK Plus, suitable for projects ranging from small one-off tools to complete application suites. GTK3 and graphics. LFS attempts to conform to the architectures discussed in the previous section. Many people do not agree with the requirements of the LSB. The main purpose of defining it is to ensure that property software will be able to be installed and run properly on a compliant system. Many people do not agree with the requirements of the LSB Linux Standard Base. The main purpose of defining it is to ensure that proprietary software will be able to be installed and run properly on a compliant system. Since LFS is source-based, the user has complete control over what packages are desired, and many choose not to install some packages that are specified by the LSB. Creating the complete LFS system capable of passing the LSB certification tests is possible, but not without many additional packages that are beyond the scope of LFS. These additional packages have installation instructions in beyond LFS. Okay. Packages supplied by LFS needed to satisfy LSB requirements. LSB core, bash, bc, binutils, coreutils, diffutils, file. These are all kinds of packages. M4, gzip, I know some of them, but some of them I've never worked with. Like, what is shadow? I don't know. What is bc? I don't know. Maybe we'll find out. I'm not gonna look for it now. Doesn't seem necessary. Desktop, none. Runtime languages, Perl. Okay, maybe we'll do some Perl learning at some point. None. LSB GTK3 and LSB graphics trial use, none. LSB Linux Standard Base. I have to remember that. Linux Standard Base. Packages supplied by Beyond LFS needed to satisfy the LSB requirements. LSB core. Oh. So these are not enough. This is just what we will learn in LFS, and in Beyond LFS we'll do other stuff as well. These are interesting. I've worked with those before. Packages not supplied by LFS or Beyond LFS needed to satisfy the LSB requirements. None. So if we get through LFS and Beyond LFS, we have an LSB compliant version of Linux that we built ourselves completely. LFS does not comply to that standard by itself. Let's go on. Rationale for packages in the book. As stated earlier, the goal of LFS is to build a complete and usable foundation level system. This includes all packages needed to replicate itself while providing a relatively minimal base from which to customize a more complete system based on the choices of the user. This does not mean that LFS is the smallest system possible. Several important packages are included that are not strictly required. The lists below document the rationale for each package in the book. Oh. Okay, let's get through the list of packages. The goal of LFS is to build a complete and usable foundation level system. All packages needed to replicate itself while providing a relatively minimal base from which to customize a more complete system based on the choices of the user. This does not mean that LFS is the smallest system possible. Several important. ACL. This package contains utilities to administer access control lists, which are used to define more fine-grained discretionary access rights for files and directories. This package contains utilities to administer access control lists, which are used to define more fine-grained discretionary access rights for files and directories. ATTR. This package contains programs for administering extended attributes on file system objects. Programs for administering extended attributes on file system objects. What are extended attributes? Extended file attributes are file system features that enable users to associate computer files with metadata not interpreted by the file system, whereas regular attributes have a purpose strictly defined by the file system, such as permissions or records of creation and modification times. Autoconf. This package contains programs for producing shell scripts that can automatically configure source code from a developer's template. It is often needed to rebuild a package after updates to the build procedures. Automake. This package contains programs for generating makefiles from a template. It is often needed to rebuild a package after updates to the build procedures. Bash. So these are all building things. Bash. This package satisfies an LSB core requirement to provide a bounce shell interface to the system. It was chosen over the other shell packages because of its common usage and extensive capabilities beyond basic shell functions. BC. This package provides an attributary precision numeric processing language. It satisfies a requirement needed when building the Linux kernel. So far, this is the only package that we directly interact with, right? No, this one also. Yes. binutils. This package contains a linker, an assembler, and other tools for handling object files. The programs in this package are needed to compile most of the packages in LFS system and beyond. Bison. This package contains the GNU version of Yak, yet another compiler needed to build several other LFS programs. Now this is a compiler, GNU version of Yak. Bzip. This package contains program for compressing and decompressing files. It is required to decompress many LFS packages, but we will build them from scratch. Why decompress them? Interesting. This package contains a test harness for other programs. It is only installed in the temporary toolchain. What's the temporary toolchain? So many questions. A Test harness for other programs. Check. Well, it's in the name. It checks programs. Core utils. This contains a number of essential programs for viewing and manipulating files and directories. These programs are needed for command line file management and are necessary for the installation procedures of every package in LFS. Deja GNU. This package contains a framework for testing other programs. It is only installed in the temporary toolchain. Another temporary toolchain. I guess the temporary toolchain is something that is a set of tools that won't make it to the final LFS system, but are used while making it. I don't know, but here it says that for each package in the book, are included that are not strictly required. All packages needed to replicate itself. Diffutils. Package contains programs that show the differences between files or directories. These programs can be used to create patches and are also used in many packages build procedures. E2FS progs. Package contains the utilities for handling ext2, ext2, ext3, and the ext4 file systems. These are the most common and thoroughly tested file systems that Linux supports. EUDEV. This package is a device manager. It dynamically controls the entities in the /dev directory, and devices are added or removed from the system as devices are added or removed from the system. expat. Package contains a relatively small XML parsing library. It is required by the XML parser Perl mode. So this is just a requirement. Expect. Package contains a program for carrying out scripted dialogues with other interactive programs. It is commonly used for testing other packages. It is only installed in the temporary toolchain. File. Package contains a utility for determining the type of a given file or files. A few packages needed to build. Find utils. Programs to find files in a file system. Used in many packages build scripts. Flex. A utility for generating programs that recognize patterns in text. It is the GNU version of the lexical analyzer program. It is required to build several LFS packages. Gawk. Programs for manipulating text files. It is the GNU version of awk. I see. Aho, Weinberg, Kernighan. Aho, Weinberg, Kernighan. It is used in many other packages build scripts. GCC. Package is the GNU compiler collection. It contains the C and C++ compilers, as well as several other not built by LFS. Come on, man. I'm so anxious to get to the meat of this stuff to build it. GDBM. GNU Database Manager Library. It is used by one of LFS package ManDB. getText. Utilities and libraries for internalization and localization of numerous packages. glibc. Main C library. There's a lot going in LFS. Linux programs would not run without it. GMP math libraries that provide useful functions for arbitrary precision arithmetic, required to build GCC. Package contains a program that generates a perfect hash function from a key set. It is required for EU dev. grep, this one we use often. Package contains programs for searching through files. These programs are used by most packages build scripts. graph, programs for processing and formatting text. One important function of these programs is to format man pages. grub, this is the bootloader. Grand Unified Bootloader is one of several bootloaders available, but is the most flexible. gzip, programs for compress. We had bzip, right? bzip too. Now with gzip as well. It is needed to decompress many packages in LFS and beyond. YANA, etc. etc. Data for network services and protocols, needed to enable proper networking capabilities. INE utils, programs for basic network administrations. INET utils, INET tool, INTL tool, tools for extracting translatable strings from source files. IP route 2, programs for basic and advanced IPv4 and IPv6 networking. It was chosen over the other common network tools package, NetTools, for its IPv6 capabilities. KBD, sounds from keyboard, key table files, keyboard utilities for non-US keyboards, and a number of console fonts. Kmod, programs needed to administer Linux kernel modules. Less, a very nice text file viewer that allows you scrolling up or down when viewing a file. It is also used by ManDB for viewing man pages. libcap, user space interfaces to the POSIX 1003.1e capabilities available in Linux kernels. libffi, a portable high-level programming interface to various calling conventions. Some programs may not know at the time of compilation what arguments are to be passed to a function. For instance, an interpreter may be told at runtime about the number and types of arguments used to call a given function. libffi can be used in such programs to provide a bridge from the interpreter program to the compiled code. libpipeline. The pipeline package contains a library for manipulating pipelines of subprocesses in a flexible and convenient way. It is required by the ManDB package. libtool package contains the GNU generic library support script. It wraps the complexity of using shared libraries in a consistent, portable interface. It is needed by the test suites in other LFS packages. Linux kernel. This package is the operating system. It is the Linux in the GNU Linux environment, M4. GNU libtool, the GNU generic library support script. M4 package contains a general text macro processor useful as a build tool for other programs. Make package contains a program for directing the building of packages. It is required by almost every package in LFS. ManDB package contains programs for finding and viewing man pages. It was chosen instead of the man package due to superior internalization capabilities. It supplies the man program, man pages. The package contains the actual contents of the basic Linux man pages. Messen, software tool for automating the building of software. The main goal for Messen is to minimize the amount of time that software developers need to spend configuring their build system. MPC, functions for the arithmetic of complex numbers. It is required by GCC. MPFR, functions for multiple precision arithmetic, required by GCC. Ninja, small build system with a focus on speed. It is designed to have its input files generated by a higher level build system and to run builds as fast as possible. Ninja, a small build system with a focus on speed. Input files generated by a higher level build system. Run builds as fast as possible. And curses, libraries for terminal independent handling of character screens. It is often used to provide cursor control for a menuing system. It is needed by a number of packages in LFS. Patch, program for modifying or creating files by applying a patch file typically created by a diff program. It is needed by the build procedure for several LFS packages. An interpreter for the runtime language Perl. It is needed for the installation and test suites of several LFS packages. pkgconfig, a program to return metadata about an installed library. How much of this gets to my head? ProcOps-ng, Pesmig, Python 3, Redline, sed, shadow. Programs for handling passwords in a secure way. Of course. syskloggd, sysinit, sysvinit, tar, another archiving and extraction, TCL, taxinfo, util-linux, vim, xml, xzlib. There's a lot. I can't wait to get through everything. After seeing all that, we get that LFS, building your LFS is not a simple task. Of course, it's not a simple task. It requires a certain level of existing knowledge of Unix system administration in order to resolve problems and correctly execute the commands listed. In particular, as an absolute minimum, you should already have the ability to use the command line SHA to copy or move files and directories, list directory and file contents, and change the current directory. It is also expected that you have a reasonable knowledge of using and installing Linux software. Fine by me. Because the LFS book assumes that at least this basic level of skill, the various LFS support forums are unlikely to be able to provide you with much assistance in these areas. You will find that your questions regarding such basic knowledge will likely go unanswered, or you will simply be referred to the LFS Essential pre-reading list. Before building LFS system, we recommend reading the following: Software Building How-To. At least I'll take a look. I don't think I'll read it. Using make, precat, packaged binaries, unpacking the files. Okay. This is a comprehensive guide to building and installing generic Unix software packages under Linux. Although it was written some time ago, it still provides a good summary of the basic techniques needed to build and install software. Beginner's Guide to Installing from Source. This guide provides a good summary of basic skills and techniques needed to build software from source code. This would be a good read, I believe. It's Make, CMake, and GCC, as far as I can tell. This goes into a lot of detail, but I'll stick to LFS. To make things easier to follow, there are a few typographical conventions used throughout this book. This section contains some examples of the typographical format found throughout LFS, throughout Linux from scratch. /configure =user from this tag. This form of text is designed to be typed exactly as seen, unless otherwise noted in the surrounding text. It is also used in the explanation sections to identify which of the commands is being referenced. In some cases, a logical line is extended to 2 or more physical lines with a backslash at the end of the line. Note that the backslash must be followed by an immediate return, otherwise, whitespace characters like spaces or tab characters will create incorrect results. Install info. This form of text, fixed with text, shows screen output, usually as the result of commands issued. This format is also used to show file names such as emphasis. This is like the same as this, but it's not bold. I don't know what about fixed with text, you say. This form of text is used for several purposes in the book. Its main purpose is to emphasize important points or items. Okay, this is an emphasis. Hyperlinks, of course, we've met them before. Used when creating configuration files. The first command tells the system to create a file. Okay. From whatever is typed on the following lines until the sequence end of line is encountered. Therefore, this is an entire section generally typed as seen. I think this is a break. Da. It's live. No. Post is live. Security live. Bye bye. N-ai văzut haina acolo? Nu. Cum n-ai văzut-o? Fii mai atent, te rog. There. This entire section is generally typed as seen. Replace text. Encapsulate text that is not typed as seen for copy-paste operations. Optional text. Pass WD5 is used to refer to a specific manual man page. The number inside parentheses indicates the specific section inside the manuals. For example, pass WD has 2 man pages per LFS installation. Instructions these 2 man pages will be located at USR share man1 passwd.1 passwd.5. When the book uses passwd5, it is specifically referring to that man passwd will print the first man page it finds that matches passwd, which will be 1 man 5, in order to read a specific page being referred to. It should be noted that most man pages do not have duplicate page names in different sections. Therefore, man program name is generally sufficient. This book is divided into the following parts: introduction, preparing for the build, explains a few important notes on how to proceed with LFS installation. This section also provides meta information about the book. Preparing for the build describes how to prepare it for the building process, making a partition, downloading the packages, and compiling temporary tools. Remember that temporary tool chain we've met? I sure remember it. LFS system. Building the LFS system. This is where the meat is. Guides the reader through the building of the LFS system, compiling and installing all the packages one by one, setting up the boost scripts and installing the kernel. The resulting Linux system is the foundation on which other software can be built to expand the system as desired. At the end of this book, there is an easy-to-use reference listing all the programs, libraries, and imports. The software used to create an LFS system is constantly being updated and enhanced. Security warnings and bug fixes may become available after the LFS book has been released. To check whether the package versions or instructions in this release of LFS need any modifications to accommodate security vulnerabilities or other bug fixes, visit that one. Before proceeding with your build, you should note any changes shown and apply them to the relevant section of the book as you process with building the LFS system. And the errata contains nothing. There are no current errata items for this version of LFS. We have successfully went through the prerequisites of Linux from scratch. Now comes the introduction. Next time on Security Live. Thank you for watching. This was your host, Emmanuel. I hope we meet again.